This is Physics 2212, Lab 1 by Krishna Medina. The introduction is the reasons for this experiment: to charge two pieces of tape, determine the interactions of the charged objects with other objects, determine the amount of excess charge on the tape, and use a simulation in Python to show the electric field interaction. The data that we collected is the charged tape had a net positive charge. The charged tape is 4.67 times 10 to the negative 9 coulombs, or 4.67 nanocoulombs. The tape is deficient 2.91 times 10 to the 10 electrons. Important equations: Newton's second law, F net equals ma. This relates the net force of the object to the mass times the acceleration. The force of gravity near Earth's surface is Fg equals mg. M is the mass and g is the gravitational constant of 9.8 meters per second squared. It acts in the y direction in this case. The force of electric charges would be K, which is 9 times 10 to the 9th, also Coulomb's constant, times your two charges, divided by your r squared, times r hat if it's in a vector. If it's magnitude, you would just take the absolute value of your magnitude, of your radius. The assumptions we made is that the tape acts as a point charge, with the center of mass located directly in the center of the tape. Another one is both tapes have the same amount of charge, air resistance is ignored, and the density of the tape is constant throughout and is only one atom layer thick. The procedure to create U-tapes is by placing one tape on the table, taping another strip on top, and ripping it off. Repeating these two steps to create two U-tapes, we observe the interaction between the U-tape and a neutral object, observe the interaction between the U-tape and a charged object, which is a plastic pen, suspend one of the U-tapes on objects of equal heights, and then place the other U-tape below the suspended U-tape and observe the separation distance. Interaction in the U-tape and a neutral object is attracting through dipole forces. Interaction to the U-tape and the pen, attracting because the pen gains electrons through abrasion. This means that the U-tape being attracted to a negative object is positively charged. Interaction in the two U-tapes is repelling as they have the same charge, and when suspended, they have a separation distance of 1 centimeter or 0.01 meters. The free body diagram: the suspended U-tape is the red circle, the surrounding is the held U-tape and the Earth. The 1 is the electric repulsion felt on the suspended U-tape from the held U-tape. 2 is the force of gravity pulling it down. 3 is the holding force from your hands on the held U-tape. 4 is the electric force repulsion from the suspended U-tape. It is at equilibrium at this point, and the U-tape is not moving. Experimental data and calculations: the tape length is 0.2 meters, tape width is 0.02 meters, tape surface area is 0.004 meters squared. Number of atoms we calculated by getting surface area divided by the area of an atom, which we multiplied the length twice to get 4 times 10 to the 17 atoms. The vertical distance between the two tapes is 0.01 meters. The tape weight is 0.00196 newtons, which we got by multiplying the density by the length and multiplying that by 9.8. The force of gravity in the U-tape as a vector is only in the y direction. The charge on the U-tape is 4.67 nanocoulombs, which we got by setting mg equal to force of electricity, or the electric force, which then, since both q's are equal, we multiply them together, and we got 4.67 nanocoulombs. The efficient electrons is equal to 2.9 times 10 to the 10, because we divided the total charge by one electron charge, and we got the number. Ratio of electrons to atom, we divided deficient electrons by every atom, and we got 1 electron is equal to 1.37 times 10 to the 7 atoms. This is the Python simulation showing the free body diagram and the same numbers. This is the code on how to make the sphere, the arrows, the vectors, and how to calculate the numbers, the charge and the deficient electrons. Discussion: the U-tape is positively charged due to missing electrons. In order to float, the force of gravity and the electric force must be equal. Possible sources of error: we may have made inaccurate measurements of the U-tape length and width, may have had an inaccurate measurement of separation distance. Held U-tape may not have been parallel to the suspended U-tape, and rounding numbers may have created some calculation errors. What if electrons had a positive charge and protons had a negative charge? The U-tape would have become negatively charged, and the electric field would have been pointing inwards. The charges would have switched, but the observation would have changed, because since the charges switched, they would both be attracted to each other, and the U-tapes would have been repelling each other. Why questions: why is it important to handle the charged U-tapes as little as possible? Because charges can spread through contact, so then they could lose their charge. and touching the charged U-tape would result in a transfer of surface electrons, which could add electrons, decreasing the electron deficiency. The U-tape would gain electrons while the hand would lose electrons.